Good evening to all. So in this particular video, I am going to discuss some of the problems of nodal analysis from chapter 4 of this book, Engineering Circuit Analysis by Hayt Kemmerly. So the first problem that I am going to discuss, it is the 8th problem in the book, and this is the circuit where we need to determine this I, right? So over here, since we need to solve the question using the nodal analysis. So in the nodal analysis, first step is to identify the nodes, and over here it is the nodes are like it is already given V1. So A, this is B node, and this is C, and this one and this one both are connected by a simple wire. There is no resistance, so it means both the nodes are same. And so we have three nodes, V, A, B and C, and let the voltage, it is given V1, V2, and for C node let the voltage be Vc. Now the second step, step 2, it is to identify the reference node. Over here the reference node, because the C node, it is connected to the maximum number of elements, so we consider C as the reference node, means Vc is equals to 0 volt. Now the next step, S3, where we need to apply the KCL at all the remaining nodes, means the voltage at Vc we know it is 0 volt because we have considered it as reference node. So we need to determine the voltage at node A and B, means we need to determine V1 and V2, right? So first we apply KCL at node A. So over here we will take that all the currents, we will consider let all the currents are going away from node A, considering the potential at node A is the highest, right? So let it be I1, let it be I2, and let this current be I3. So it means that I1 plus I2 plus I3 will be equal to 0 as per the KCL. Now the current I, you can see that the given this current source and the direction of I1, they are in opposite direction, so we will take it as -5 plus I2. I2 is the current flowing from node A to C, so it will be V1 minus Vc upon resistance, which is 1. Now Vc is 0, so over here I can, or I will remove Vc after in the next step. Now I3, it is a current between node A and node B, right? So this is I3. So we will write V1 minus V2 upon resistance in between, which is 5. So this is our equation. If I solve this, so Vc is 0, so I will get -5 plus V1 minus V1 upon 1 plus V1 minus V2 upon 5. Let me take the LCM as 5, so it will be -25 plus 5V1 plus V1 minus V2 equal to 0. So overall I will get the equation as 6V1 minus V2 equals to 25. So this will be our first equation, right, after applying the KCL at node A. Now similar to node A, now I will apply the KCL at node B, right? So applying KCL at node B, and again I will assume that let all the currents, they are going away from node B, assuming that B has the highest potential, and let the current over here, let it be I4, this one I5, and this one I6, right? So it means as per the KCL, it will be I4 plus I5 plus I6 will be equal to 0. Now I need to determine the value of I4. Now I4 is this current from B to A, right? From B to A. So it will be V2 minus V1 upon 5 plus I5. Now I5 is this current, right, flowing from this B node to C node, right? So, and since C is 0, VC is 0, so it will be V2 upon resistance, which is 2, right? And then I6. Now I6 is this current, and this I6, it is in the same direction as this current source direction, so I6 will be plus 4. So this will be our equation. And now taking the LCM of this, 10, so it will be V2 minus V1 2 plus 5V2 and plus 40 equal to 0. Solving this, we get minus 2V1 plus this 2V2 plus 5V2, so 7V2 and plus 40, so equal to minus 40. So this is our second equation. So means I got two equations. One equation is 6V1, let me write it over here. 6V1 minus V2 equals to 25. This was our first equation. Now if we solve these two equations using the calculator or manually, so over here I am directly writing the values of V1 and V2. So you will get V1 as 27 by 8 and V2 as minus 38 by 8 volt. Right? Now let me go to the question. The question is asking, we need to determine the I. What is I? I is the current that is flowing from V1 to V2. This is I. So it means our I, it will be V1 minus V2 upon resistance, which is 5. Remember that this will be V1 minus V2, not V2 minus V1, because the current always flow from high potential to low potential. So since over here it is considered that the current is going from V1 to V2, so it means that V1 has the higher potential, right? So I is V1 minus V2 upon 5. So substituting this value, I equals to V1 minus V2 upon 5. Substituting these values, I will get 27 by 8 minus 38 by 8 upon 5. So I will get this 27 and this becomes plus, minus becomes plus. So 27 and 38, it will be 50, 65 upon 8 into 5. So 5 and 13. So our current I, value of I, it is 13 by 8 amperes. So this is answer to the first question. Now after this, coming to the second question, and the second question is the 12th question in the book, taken from Hayt and Kemmerly. So over here the question is saying that we need to determine this VP, this voltage. So again, since we need to do it using the nodal analysis, so first step will be to identify the nodes. Now over here, the first node is A, second node is B, third node is C, this is another node D, and this at the downside, this is E. And all the nodes, since they are connected by a straight wire, so all the nodes are same, right? So, and we will take this E as the reference node, right? Means this V, potential at V, it is 0 volt, right? Now once we get the 4 nodes, now we need to write the KCL at all the 4 nodes A, B, C and D. So writing the KCL at A, node A, so we will get, now again we will follow the same pattern. Current is going away from node A, so over here I1, I2, I3, right? So I1 plus I2 plus I3 equal to 0. I1, now I1 is the direction of I1 is opposite to this, so it means I1 will be minus 10 plus I2. I2 is the current flowing from A to E. So since VE is 0, so I2 will be VA upon 20 plus I3. I3 is the current flowing from A to B. A to B. So it will be VA minus VB upon 40 equal to 0. And solving this equation, taking the LCM as 40, we get this will be minus 400 plus 2VA plus VA minus VB. So our first equation equal to 0. So our first equation, it will be 3VA minus VB is equals to 400. So this is our first equation. Now coming to second one. Now applying KCL at B. It will be again taking the same concept that current is just away, right? So over here, let me write the equation directly without giving the number as I4, I5, I6. So without this also we can directly write, right? So I4 is the current flowing from B to A. So this will be VB minus VA upon resistance, which is 40, plus this current, so B to E. So it is VB upon 100 because VE is 0 since it is a reference node, and I6, it is the current flowing from B to C. So VB minus VC upon 50, and it is equals to 0, right? And now again solving this equation, if you solve this equation, like I take the LCM, it will be 200, right? It will be 200, so it will be 5 VB minus VA plus 2 VB plus 4 VB minus VC, and it is equals to 0. And now solving this particular equation, we have only one VA, so it is minus 5 VA, 5 VA plus 2 means 7 VA plus 4 means plus 11 VB, and then VC, it is plus 4 VC. Oh, not 4, it is minus 4 VC, it is equals to 0. So this is our equation number 2. Now following the same thing, now we will apply the KCL at node C. KCL at node C. Over here again, first this current, so C2B, it will be VC minus VB upon 50 plus this current, and it is already given, so I will write it directly 2.5. Then C2D, this current, since 2 ampere it is in opposite direction, so I will take it as minus 2, and then this current, so it will be plus VC minus VD upon 10 equal to 0, right? And now solving this we get, over here we can take the LCM as 50, so it is VC minus VB plus this together, it is 0.5, so 0.5 into 50, it will be 25 plus 5 VC minus VD equal to 0, right? So over here we have VB, so minus VB, then VC and VC, so it is 6 VC, and this is minus 5 VD, and this is plus 25, so I will take it on the other side, so it is minus 25. So this is my third equation. Now last we need to apply the KCL at node D. So applying KCL at node D, The first is this, let me take this current, so it is 2, plus let me take this current, so it will be VD minus VC upon 10. Let me take this current, it is in opposite to 5 ampere, so minus 5, and then this current, so it is VD minus VE upon 200 equal to 0, right? So over here taking the LCM as 200. If I take the LCM as 200, now this 2 and this is minus 5, so this becomes minus 3, so minus 3 into 200, so it will be 600. Then plus this term, so it will be multiplied with 20, so VD minus VC, and then this term it will remain as it is, equal to 0, right? So now over here we have VC, so minus 20 VC, then VD, 20 VD plus 1 VD, so it is 21 VD, and then VE, over here VE is 0, it is 0, so we can remove it, and this is minus 600, so taking it on the other side we get this. So this is our fourth equation. So we have in total we got 4 equations, right? The first one, the second one, the third one, and the fourth one, right? And if we solve this, then you will get the following values. VA will be equals to 190.55 volt, VB equals to 171.64 volt, VC will be equals to 233.82 volt, and VD will be equals to 251.26 volt, and VE is 0 volt, right? So you can solve these equations either in a calculator, using the calculator, or using any online tool, or you can do it manually. So after this, let us go back to the question that what we need to determine. So as per the question, it is given that we need to determine the VP, means this, and if you see that this plus sign, it is towards B node, and this minus, it is E, so it means VP, it will be equals to VB minus VE, right? And since VE is 0, so it will be equals to VB, right? So our VP will be equals to VB, right? So what we get, our VB, it is this, right? So it means the answer to this question, it is 171.64 volt, right? So now going to the third question. So in total I am going to solve 7 questions. So it is the third question, which is question number 14 in the book. So over here again applying the nodal analysis, and but before applying the nodal analysis, what we need to do, we need to determine the nodes, right? So over here, this is the first node, this is second node, this is third node, this is fourth node, and this is fifth node. So in total, step 1, in total we have A, B, C, D and E. We have 5 nodes, and let the voltage over at all the nodes, let it be VA, VB, VC, VD and VE. Second step, we need to identify the reference node. Now over here, out of this 5 nodes, this one C, it is the node which is connected to the maximum number of branches. So to make our calculation easy, we are going to consider this C as a reference node. It means that VC will be equals to 0 volt. Now in step 3, we are going to apply KCL for all the remaining nodes. Means we are going to apply KCL for A, B, D and E, right? So applying KCL at KCL at node A. So one current is this. This current will be VA minus VB upon 1 plus second current is this, which is VA minus VC. VC is 0, so simply I will write VA upon 3. Then third current, this is also A, right? Because this is just connected by a straight wire, right? So it means third current will be this. So it will be VA minus VD upon 4. And the fourth current is this, which, and this is in opposite to the 2A. So I will write minus 2A equal to 0. And now solving this equation, I will get, like, let me take the LCM. So it will be, LCM will be 12, and this 12 VA minus VB plus 4VA plus 3 VA minus VD minus 24 is equals to 0. It is equals to 0, right? So now it is 12 VA plus 4 16 plus 3, it is 19 VA, then minus 12 VB, then we have this VD, so minus 3 VD, and this is 24. I take it on the other side, so it is 24. So this is our first equation. Now applying KCL at node V, it is, let me put this as, right. So applying KCL at node B. So applying KCL at node B. So one current is this, so it will be VB minus VA upon 1. Second current is this, which is 3. Since the current is this source, the direction is away from node B, so it is plus 3. And the third is this, and it is VB minus VE. Now VB minus VE upon 2 equal to 0. Remember, our reference node is this C, so it VE is not 0. And now solving this equation, I will get, this is LCM is 2, so 2 VB minus VA plus 6 plus VB minus VE equal to 0. So it will be minus 2 VA, then 2 VB plus VB, so it is 3 VB, and then minus VE, it is equals to minus 6. So this is our second equation. Now in the third, applying KCL at node C, because C is a reference node, so I will apply at node D. Now at node D, one current is going up and it is node A, right? So the first will be VD minus VA upon 4 plus second current is this, VD minus VC. VC is 0 since it is a reference node, so it will be VD upon 7. And the third current is this, which is coming towards E, from D to E, so it will be VD minus VE upon 6 equal to 0. And now solving this equation, over here the LCM, it will be 642, it will be 84, right? So this the first one, it will be multiplied with 21 VD minus VA plus second one, it will be multiplied with 12, and the third one, it will be multiplied with 14. and solving, like over here VA, it is minus 21 VA, then VB is not there, VC is not there, VD, 21 VD plus 12, 21 plus 12 is 23, 33 plus 14, it is 33, 37, 47, so 47 VD, and then VE, it is minus 14 VE, it is equals to 0. So this is our third equation. Now applying KCL A, B, C, D, E. So applying KCL at E. So one current is going towards B, so it will be VE minus VB upon 2. Second current is going towards C, so it will be VE minus VC, VC is 0, so just VE upon 5. Third current, now this is just a straight wire, so it means the third current will be this, going towards D, so it will be VE minus VD upon 6, and the fourth current is this, which is 2 ampere, so plus 2 equal to 0, right? And now taking the LCM as 30, so it will be multiplied with 15 plus this will, second term, it will be multiplied with 6, and the third term it will be multiplied with 5, and this 2 it will be multiplied with 30, so it will become plus 60, and this is equal to 0, right? So over here VB, so minus 15 VB, then VD is there, so it is minus 5 VD, and then VE 15 plus 6, it is 21, plus 5, it is 26, so plus 26 VE is equals to, and this is 60, so I take it on the right side and it becomes minus 60. So this is our fourth equation. So the four equations that we got the equation, this is our first equation, this is our second equation, this one, this is our third equation, and this is our fourth equation. Now if you solve this four equations, so you will get VA as minus 3.42 volt, VB as minus 6.54 volt, VC as minus 3.54 volt, and sorry, not VC, it is VD, and VE, it is minus 6.76 volt, and VC, which is our reference node, it is 0 volt, right? So now going back to the question, that what exactly we need to determine. So over here in this question we need to use nodal analysis to determine I5. So we need to determine this current, and this current is flowing from C towards E, right? So this I5, it will be expressed as VC minus VE upon 5, right? So yes, over here, so our I5, this I5, it will be VC minus VE, this is C, this is E, so VC minus VE upon 5. Now VC is 0 minus VE is this minus 6.76 upon 5, right? So it is 6.76 upon 5, and it is equals to 1.35 amperes. So this is our answer, right? So with this I will move to the next question, and it is the 16th question of the chapter 4 of this book. So over here we need to determine the I2 with using the nodal analysis. So again the steps will be that first of all we need to identify the nodes. So over here, the first node, let it be A, the second node, let it be B, this let it be C, and this let it be D. So step 1, nodes, it is A, B, C and D, and let the voltage at these nodes, let it be VA, VB, VC and VD. Second step, we need to determine the reference node. So over here you can see that this D, it is at the negative terminal of this, plus it is connected to the maximum element, right? So but not maximum, because all these A, B, C and D all are connected with 3 branches, right? But the additional part with the D is that it is connected to this negative terminal, means the current is going up. So, and we will take the reference node as D and let the voltage, if it is the reference node, then VD will be 0 volt. Now third step, we need to write the KCL equations for all the nodes, means for A, B and C. So if I apply the KCL at A, so the first current, let it be this. So it will be VA minus VC upon 5, plus second is this, so it will be VA minus VB upon 3, and the third, it is this, and this is in opposite direction to this dependent current source, so it will be minus 0.02 V1 equal to 0, right? Now what is V1? If you look at this, V1 is plus is towards C, minus is towards B, so it means that our V1, it will be VC minus VB, right? So I will substitute this value VC minus VB over here. So substituting this value, so I will get VA minus VC upon 5 plus VA minus VB upon 3 minus, let me put this as, so it is 1, it is 50, so 1 by 50, and V1 is VC minus VB as we determined from it. And now taking the LCM over here, the LCM I will take it as 150, so 150, so it will be multiplied with 30, this second term, it will be multiplied with 50, and this third one, it will be multiplied with 3, and it is equal to 0, right? Now VA 30 VA plus 50 VA, it is 80 VA, then VB minus 50 VB, and it is minus and minus, this is minus and minus, so it becomes plus, right? So it will become let me check, okay, so it is minus 50 VB plus 3 VB, so it is 47 VB, and then VC minus 30 VC, let me change the pen, so it is minus 30 VC and minus 3 VC, so it will be minus 33 VC equal to 0. So this is our first equation. Now writing the KCL for node B. For writing the KCL for B, first current, let it be this, so it will be VB minus VA upon 3. Second, let it be this, so VB minus VC upon 2, and the third, let it be this, and since the direction of this and the current source, they are in opposite direction, so it means it will be minus 10 equal to 0. Now solving this means taking the LCM as 6, we get 2 VB minus VA plus 3 VB minus VC and minus 60 equal to 0. So we get minus 2 VA, then this 2 VB plus 3 VB, so it is 5 VB, and minus 3 VC is equals to 60. I have taken this minus 60 on the right side, so it is 60. So this is our second equation, right? And now taking the KCL, writing the KCL for node C, KCL for C. So over here the first current, let it be this, so it is VC minus VA upon 5. Second current is this, so it will be VC minus VB upon 2, and the third is this, which is in opposite direction to this, so it will be minus 0.2 V3 equal to 0. Now V3 is this, right? So over here V3, since plus sign it is towards C terminal, so over V3 it will be VC minus VA, because minus is towards the A terminal, A node, right? So V3 will be VC minus VA. So I can rewrite this equation as VC minus VA upon 5 plus VC minus VB upon 2 minus, let me take this as this, so it becomes 1 upon 5. So 1 upon 5 and V3 I just determine it as this, VC minus VA. So I will put VC minus VA and it is equals to 0. Now over here, if you look at this term, first term and the last term, they are same, so they will be cancelled out, and we're left with only one term, which is this, right? So it means we get VC minus VB equal to 0. So VC is equals to VB. So this is our third equation. Or simply if I substitute this value of VC and VB in these equations, in equation 1 and in equation 2, so what I will get that VA is equals to VB is equals to VC. So this is what I will get after substituting the value of this value in equation 2 and 3, right? So once I get this, now again go back to the question. Over here, what we need to determine? We need to determine the current I2. What is this current? The current, this I2 current, it is moving from C terminal towards the A terminal. So our I2, it is VC minus VA upon resistance, which is 5. Now since all the three node voltages, since they are same, so it means I can write VC minus, and VA can also be written as VC upon 5. So it will be 0 upon 5. It means 0 ampere. Means no current is going to flow in this branch. And since the node voltages, all the three node voltages are coming out to be same, so it means the current is 0, because current flow from high potential to low potential, right? And since the potential VA, VB and VC all are coming equal, so means there cannot be any current in between these three nodes. So with this, let me move to the next question, which is question number 18 of the book, and this is our 6th problem. After this I will solve 2 more questions. So over here again, the first step is to identify the nodes. Over here nodes are, let it be A, B, C and D. So A, B, C and D, and it is already given that reference node is D, means VD is 0, and over here A voltage is V1, B voltage is V2 and C voltage is V3, and D voltage it is becoming 0, right? So now simply we need to apply KCL. Third step, KCL at A. So the first current, let me take this one. So since it is in opposite direction to this one, so it will be -3. Second, this one, so it will be plus V1 minus V2 upon resistance, which is 5. Third current, this, since it is in the same direction as the current source, so it will be plus 5. And then this one, so it will be V1 minus V3 upon 1 equal to 0, right? So solving this one means taking the LCM as 5, I will get this -3 and +5, it becomes 2, and 2 into LCM means it becomes 10, plus this V1 minus V2 and plus 5 V1 minus this will be multiplied by with 5, so equal to 0. Wait a minute. Just a minute, there is some problem with the pen. Yes, so it is 0, right? So it means our first equation now over here V1 plus 5V1, so it becomes 6V1 minus V2 and minus 5V3, and then 10, I will take it towards the right side, so it becomes minus 10. So this is my first equation. Now writing KCL at B. So at B, again let me take this first current as this, so it will be V1 minus V2, V2 minus V1 upon 5. Second, this current, and this is in opposite direction to the source, so it will be taken as -5. Then the third current will be this, but over here you can note that over here it is a voltage source, right? So it means I do not know what is the exact current that is flowing. So, and we know that whenever the two nodes are connected just by a voltage source and there is no resistance in between, it means that what we are going to do, we are going to form a super node. It means that we will combine V2 and V3, and all the currents, like over here we will consider the current as one current I1, second current I2, third current we will consider is I3, and then we will come to the V3 terminal and we will consider these currents I4, I5 and I6, right? So we will combine, we will create a super node and we will write the KCL for node B and C together. So writing that KCL at super node B and C. So let me erase this. So the first equation, so let me write for I1. So I1, the I1 is, it is in opposite direction to this, so I will write -5, right? Or let me put it over here. So this is our B terminal, B node, this is C, and it forms the super node. So the first is this, so it will be -5, since it is in opposite, this current I1, it is in opposite direction to 5 ampere. Second, let me take it as this, so it will be plus V2 minus V1 upon 5. Third, let me take it as this, so V2 minus 0, so plus V2 upon resistance. Now after this I will take this one, so it will be plus V3 minus V1 upon resistance 1. Then this one, it is V3 minus reference, so V3 upon resistance. And then this one, which is in the same direction as the current, so it will be plus 8 equal to 0, right? And now if I take the LCM, which will be 30, so LCM, it will be 30, so minus 5 into 30, it will be minus 150, plus this second term, it will be multiplied with 6, so 6 V2 minus 6 V1, then this it will be multiplied with 10, then this it will be multiplied with 30, then 15 V3, and then this it will be multiplied with 30, so plus 240, right? So and it is equal to 0. Now after this, first V1, so we have this 10 V1 minus 30, so it will be minus, and this also, right? So we get 10 minus 30, it is minus 20, and minus 6, so it is minus 26 V1, right? Minus 26 V1. Let me check it again. Do we left with anything else? Just a minute. 6 V2, 6 V1. Okay, minus 30 V1. I guess I did something mistake. Yes, over here this is our V2, so it is 10 V2, not V1, right? So that was the mistake I did. So now it is minus 30 V1 and minus 6, so it will be minus 36 V1. Then V2 is 10 V2 plus 6 V2, so it is 16 V2. Then V3, it is 30 V3 and 15 V3, so plus 45 V3, and then we left with 240 minus 150, so it is plus 90 equal to 0, or I can take 90 on the right side to make it as equal to minus 90. So this is our second equation. So the first equation we get by applying KCL at node A, we get this. Second equation we get by applying the KCL at the supernode, and the third we will get from the supernode. Now our supernode is this, right? So over here it is given that plus terminal of the voltage, it is towards B node, right? So it means that VB minus, sorry, not VB, V2 minus V3, it is equals to 4. So this will be our third equation, and solving these three equations we will get the value of V1 as minus 8.6 volt, V2 as minus 3.6 volt, and V3 as minus 7.6 volt, right? So let me check what we need to determine in the question. So it is asking determine the nodal voltages, so we need to determine V1, V2 and V3. So we have determined this, right? So this we have determined. Now moving to the next question, which is our second last problem that we are going to discuss today. So over here we need to determine Vx in the circuit. Vx is this, and we also need to determine the voltage supplied by this 1 ampere current source. So to do this, again we will follow our nodal analysis, and to apply the nodal analysis, what we need to do, we need to determine the nodes. So this will be our nodes, right? So nodes, first step nodes S1. So nodes are A, B, C and D, and let the voltages be VA, VB, VC and VB. Second step S2, reference node. So reference node we will take it as VD equal to 0, means reference node we have taken as D, right? So VD will be considered as 0 volt. And now we need to apply the KCL. So applying the KCL at node A. Now if you apply KCL at node A, then you will find out that this again, this over here, this node A and node C, they are interconnected by a current source. It means node A and node C, they are forming a supernode. And if they are forming a supernode, it means we are going to write KCL for node A and C together. Means over here we will write KCL for supernode BAC, supernode AC. So we will consider this current. First let me consider this. So it is -1, then this, it is VA minus VB upon resistance 8. Now we cannot consider this one, we cannot consider this because it is a voltage source. So we will come to the C node, and in the C node we will consider this current, and since it is opposite to 8 ampere, so I will write -8, and then this current, so it is VC minus VD. VD is 0, so I will write VC upon 2, and it is equal to 0. So means by applying KCL at the supernode we get this equation, and taking the LCM for this, it will be 8. So -8 plus VA minus VB, this -64 plus 4 VC is equals to 0. Now VA minus VB plus 4 VC and -8 and -64, it will be 72. So -72, taking it on the right side, I will get this. So this will be our equation number 1. Right? Now we also know that whenever we get a supernode, means over here we get a supernode we create a supernode by combining A and C. So from supernode we get another equation, and over here, since the positive terminal is connected towards C node, so it means we will get VC minus VA, it is equals to 2Vx. And now what is Vx? Now Vx, positive terminal of Vx, it is connected to B terminal, and negative is connected to D terminal, which is 0. So our Vx, it will be VB minus VD, because positive terminal of Vx is connected towards B node, and since VD is 0, so it means Vx is equals to VB, right? So it means that in this we will write VC minus VA is equals to 2VB. So this is our second equation, right? Now we left with, we apply the KCL at supernode AC. Now we will apply the KCL at node B. So applying the KCL at node B, KCL at node B, we get, first let me take this current, so it is VB minus VA upon 8. Second, let me consider this current, so it is VB minus D, VB minus VD. VD is 0, so I will consider only VB upon resistance 5, and then this current, and it is given as 8, so plus 8 equals to 0. Taking the LCM as 40, so I will get 5 VB minus VA plus 8 VB plus 8 into 40, so it will be 320 equal to 0, right? And solving this, like, we will get minus 5 VA minus 5 VA, and then VB 5 VB plus 8 VB, so it is 13 VB, and this is plus 320. Taking it on the right side, I will get it as minus 320. So this will be our equation number 3. So we get 3 equations: first equation, second equation, and the third equation, right? And we have 3 unknowns: VA, VB, and VC. So if you solve these equations using the calculator or manually, so you will get VA is equals to 31.76 volt, VB as minus 12.4 volt, and VC as 6.96 volt, right? Now let's check what we need to determine. Over here in this question, we need to determine the value of Vx, and Vx is VB. So it means the first part we have already determined. It is Vx, it is equal to VB. So it means Vx is minus 12.4 volt. This is first. Now the second question, it is, let me just a minute please. Okay, yes. So the next question is, over here it is power supplied by 1 ampere source. So we need to determine what is the power supplied by this 1 ampere, right? So over here 1 ampere current is already given. So we need to determine what is the voltage across this. Voltage across this means plus and minus. Why plus at the top? Because current is going in this direction, and since it is the source, so plus will be over here, minus over here, because we know that if there is a voltage source, so current always move away from the positive terminal, right? So it is the reason that we will put plus at the top, right, for the current source. And since we need to determine the power supplied, right? So over here, if plus is at the top, so this voltage, let it be V1. So this V1, it will be VA, because A node is towards the positive terminal, so VA minus VD, and VD is 0, so it is equals to VA, and VA is this 31.76 volt, right? So we know, now we know the voltage, we know the ampere. It means power is equals to V1 into I, right? So it will be, power will be 31.76 watt. So this is answer to the second part of the question, right? Now moving to the last question. Okay, so coming to the last question, over here we need to determine all the 4 nodes, right? So again, first of all, it is given that we have 4 nodes. So let me number this. So over here it is, let it be A, or let it be A, B, C, and D, and this is already given, so let it be E, right? And means we have 5 nodes, voltages at all the 4 nodes are given, and since E is the reference node, so it means VE is equals to 0 volt. Now applying the KCL at node A. Now since node A is there is a voltage source between node A and the reference node, so over here we do not need to write a KCL, because the purpose of writing a KCL is to determine the unknown voltages, unknown node voltages. Now over here, if you look that over here we have a voltage source, and the plus terminal is towards node A, negative is towards node E, which is a reference node and which is 0. So it means that VA minus VE, it is equal to this voltage source, which is 1. And now VE is given as it is 0 since we have considered it as a reference node. So it means that our VA, it is 1 volt. So directly we get VA as 1 volt, right? So we do not need to write KCL for this node A, right? Now coming to node B. So writing KCL at B. So first let me consider this current. So it is VB minus VA upon 1. Let me consider this since it is opposite to the direction of the current source, so minus 3, and then this, so it is not VB, it is V2, right? V2 minus V1. VA instead of VA, let me put V1 because it is given in the question, right? So writing this, so it will be plus V2 minus V3 upon resistance, which is 2. Now solving this, we get 2, LCM is 2, so V2 minus V1 minus 6 plus V2 minus V3, right? So it is equal to 0. And so we get V1 minus 2V1, then this V2 and this, so it will be 3V2 and minus V3, and this is minus 6, so I will take it on the right side, so it is 6. So this is our second equation. First I will consider this one, means V1 is equal to 1 volt. Now writing our KCL for node C. So writing KCL, let me put it as A, B, C, D. So writing KCL at C. So I will first consider this. So it is V3 minus V2 upon 2. Let me consider this one. It is V3 minus V4 upon 1. And then this, and it is a current source, so it is 2Vx equal to 0. Now what is Vx? Vx is this. Now since the positive terminal of this Vx, it is connected to C terminal and negative is connected to D terminal, so it means that our Vx, it is equals to Vc, means V3 minus V4. So I will put this, instead of this Vx, I will put V3 minus V4. So V3 minus V2 upon 2 plus V3 minus V4 plus 2 V3 minus V4 equal to 0, right? And over here, this V3 minus V4 and this and this are same, so I will put, in place of 2, I will put it as 3, and I will remove this. Now taking the LCM, I will get 2, and this is V3 minus V2, and plus this 3 becomes 6, and V3 minus V4, it is equal to 0, right? And now this V3 plus 6V3, so it is 7V3, then it is minus V2, so we will put minus V2 over here, and then minus 6V4 equal to 0. So this is our third equation, right? This is our third equation. And now we will write the KCL for D. It is D. So KCL at D. So first let me write KCL for this. So it is V4 minus V1 upon resistance, which is 4. This one, it is V4 minus reference, which is 0. So plus V4 upon 3. And then this, it is V4 minus V3 upon 1. And it is equal to 0. So again taking the LCM as 12. So it will be 3 of V4 minus V1 plus 4 of V4 and then 12 V4 minus V3 equal to 0, right? So we get over here it is minus yes, so it is minus 3V1, right? Then V2 is not there, then V3, so it is minus 12V3 and then V4, 3V4 plus 4V4, it is 7 plus 12, so it is 19V4 equal to 0. So this will be our fourth equation. And now solving all these four equations, you will get the value of V1 as 1 volt, which we already have obtained, V2 as 3.09, it is 3.09, V3 it is 1.26 volt, and V4 it is 0.95 volt. And this is what we need to determine in this question, that we need to determine the 4 nodal voltages. So in this way we can apply the nodal analysis to the circuit to solve the values. And in all the questions that we have discussed, just we need to follow the 4 steps. First, identification of the node. Second step, to identify the reference node and make it as 0. And then simply we need to write the KCL for all the remaining nodes. And then in the last step, simply we need to solve the equations to get the values of the nodal voltages. And once we get the nodal voltages, then we can determine the voltage drop across any element or the current flowing through any element. So this is all from my side. So if you have any question, any doubts, then you can put it in a chat box. So do subscribe my channel. Thank you.